what we do best. We're continuing with organic chemistry. Today I want us to talk about the intermolecular forces. The intermolecular forces which we find in different organic molecules. In grade 11, I told you about intermolecular forces. And I told you that intermolecular forces, these are bonds which exist between atoms, which hold atoms together. And depending on the type of an intermolecular force, which will be between atoms, these intermolecular forces, they will determine whether the molecule will have a high boiling point or a low boiling point, also the vapor pressure. So you can liken intermolecular forces like when I am taking my hands, the palm of my hand, and I fasten them like this, right? If I am stronger enough, if people may come and try to pull so that the grip and the grasp of my hands can break, depending on my strength, they will be able to do it, right? So if the grip is more stronger, it means it will be difficult for them to do what? To break my grip. You understand? So you can liken that to intermolecular forces. These intermolecular forces are different, of which in organic chemistry we are going to talk more about London forces and hydrogen bond. We have many types of intermolecular forces, which I told you. We have dipole, right? We have got induced dipole, right? Yes, I told you that. And we have got the van der Waals forces. We have van der Waals forces, right? We have van der Waals forces. And we have got the hydrogen bond. And I told you that hydrogen bond is one of the strongest intermolecular forces that exist, right? And we know that hydrogen bond exists between the north and hydrogen, right? By north, we're talking about nitrogen, oxygen, and fluorine, right? And all these, they get to form hydrogen bond where there is what? Hydrogen, which will bond with these three atoms. North, we just call them north. It's a mnemonic device so that we know that this north stands for nitrogen, oxygen, and fluorine. But before we talk about hydrogen bond as an intermolecular force, I need to bring it to your attention that even if we have the weak intermolecular forces like London forces, if these London forces they occur at a larger surface area, sometimes they cause or they give organic molecules the properties like having a high boiling point when they occur at a larger surface area. What do I mean by a larger surface area? When I teach, I usually love to do demonstrations, right? Let's say I'm trying to create a bond between my fingers, right? It is more easier to break these attachments of my finger, right? When it is like this. I can liken this demonstration as a smaller surface area. When we talk about the surface area, we're talking about the what? the space. You understand? We're talking about the space. So I can say that these two attachments between my fingers, it is occurring at a smaller surface area when we compare to this attachment. Do you agree? And this one is a smaller surface area when we compare to this attachment, right? And this one is a smaller surface area when we compare to this attachment. Between this attachment and this attachment, which one is stronger? It is this one, right? This one, it is a bit weaker. But these attachments, they are the same. It's finger to finger, right? But although it's finger to finger, this one is more stronger because I have a what? A lot of fingers attaching together, other than having two fingers attaching together, right? So what I'm trying to bring home is, even if we have weak intermolecular forces such as the van der Waals forces or London forces, it is possible that the bond that can exist, they can be strong because of their surface area. Do you understand that? Yes. Is it difficult to understand? When we talk about surface area, we're talking about what? We're talking about the space, right? Yes. So it's possible that the intermolecular forces can occur at a smaller space or can occur at a larger space. You understand, right? So now, there's no exam without this, ne? There is no exam without this. Remember, I'm not only just teaching you for final exam, I'm also teaching you for continuous assessment, because they also contribute to your SBA, right? They also contribute to your year mark, yeah? So there is no exam without this. You understand? So now, let us compare, maybe let us talk about the alkanes. Let us talk about the alkanes. Let us talk about the what? The alkanes. Is everything okay? Yes. You know, when physics is inside of you and you get to enjoy it, you get to do what I'm doing. You understand? Yes. After all, you cannot teach physics and you become normal. You must be crazy a little bit to understand. Yeah, so physics is yeah, so you don't say in physics. You understand talent. Yes. Talent doesn't go boss. I want us to talk about what? Alkanes. Let's say we have this one. I'm just going to demonstrate it using can you see this one? I will start from just a simple one. What's the name of this alkane? 0. The next day, then? Let me just give you this one. What about the name of this one? It's a propane. So I have a hexane, right? As you said, hexane and propane. So what's happening? You see, this one is longer. You see? Yes. This one is a bit shorter. Do you agree? Yes. So, you want to compare the intermolecular forces between the two. And we know that when we compare the intermolecular forces, we eventually talk about the boiling point and the vapor pressure, right? Yes. And the type of energy which is needed to break the bonds. Right? Yes. Okay. Actually, let me outline the things which we need to talk about. Whenever we talk about the intermolecular forces, this is what we need to talk about. Type of intermolecular force. Intermolecular force. Whenever you come across a question which will need you to talk about the intermolecular force, you talk about this things which I'm going to list here, right? You must talk about the what? The type of the intermolecular force, right? It means you are going to give the name of the intermolecular force, for example, or you say something about the what? The intermolecular force, right? Then you talk about the type of energy. You talk about the type of energy needed. Energy needed, I don't have space, I won't write. Energy needed. In other words, it's either you will say that more energy is needed to break the bonds, right? Yeah. Or less energy is needed to what? To break the bonds. Then when you have talked about the energy, you talk about the what? The what? The boiling point. The boiling point. You talk about the what? The boiling point. It's either the boiling point will be low or the boiling point will be higher. Right? Okay. So it means the type. Let me give you an example. Let's say we have the type of intermolecular force is hydrogen bond, right? We know that the type of this intermolecular force, if it's a hydrogen bond, okay, let me add. It means you need to give the type of the intermolecular force, right? Yeah. Whether it is stronger or it is weaker. Then I think the first thing, give what? The name of the intermolecular force. Molecular force. So here, let me say strength. Strength. Yeah. It's better to write it there. The first thing you give the what? The name of the intermolecular force. Then you give the strength of the intermolecular force. Then you talk about the type of energy that is needed. Then you talk about the boiling point. And you know that when we talk about the boiling point, we eventually talk about the what? The vapor pressure. Vapor pressure. Because we know that vapor pressure is what? Is inversely proportional to boiling point, right? Yeah. So whenever you come across a question that will request you to address the issue of intermolecular force, it means you must give us the name of the intermolecular force. You must give us the strength of the intermolecular force. You must give us the type of energy that is needed. You must give us the what? The boiling point. And you can even be able to manipulate them. You talk about the vapor pressure. So this is how you need to address. Whenever you come across a question that talks about intermolecular forces, make sure that you touch on the 4 things which are highlighted. You can even write them in point form. They must be clear. You can even write a bullet. You give us the name of the intermolecular force. You write a bullet. You give us the strength. Let's say we are dealing with a question that is talking about the what? The hydrogen bond. It means the name is what? Hydrogen bond. The strength of hydrogen bond, it means hydrogen bond you have got there is a strong intermolecular force. The type of energy that will be needed to break the bond, it means more energy is needed to break the bond. The boiling point, it means the boiling point will be high. Because the boiling point is high because stronger intermolecular force, it means the forces which are holding molecules are stronger, right? So it means it won't be easy for that molecule to reach its boiling point. It will take more time. You understand, right? Yes. I've addressed these things. Né? Okay, now, please, these things are not related to the things which I drew here. There are 2 types. There's no hydrogen bond. You know that hydrogen bond exists between north and what? And hydrogen, right? So I want to talk about intermolecular forces, but it's not this. Because these things of intermolecular forces in organic chemistry, they appear in 2 forms. They will appear to the alkanes, then we'll deal with them to the carboxylic acid alcohol, those organic molecules that they have got oxygen, right? That's where we'll talk about intermolecular forces. But as far as this one, the alkanes are concerned, we won't talk about hydrogen bond. We'll be talking about surface area. Remember in grade 11 when I was teaching you, I used to tell you that there is a topic in grade 12 which we are going to exhaust, which is related to there. Okay. Wow. Back to Limpopo. Let's address this. That's what will happen, guys. Okay. If you check these two, can you see them? 1, 2, 3, 4, 5, 6. Is it 6? It's a hexane. Can you see?
Yeah.
This one is a propane. This one, which one have got a larger surface area? Which one have got the larger space? Which one? Is it number 1 or number 2? Carry, are you able to see? You are able to see that number 1 have got larger space, right?
Yeah.
Space. And when we talk about space, we're talking about what? Surface area. So it means this one have got a larger surface area. Surface area, larger. It is larger when it is being compared with this one. This one has got the what? A smaller surface area. A smaller surface area. So I want us to talk about the what? The intermolecular force between the two. You want to compare, right? Yeah. When we have a shorter chain and a longer chain. Because a question of the experiment, it may come which it will request you to compare. That tell us about the boiling point of this one. So you need to know. So look, when objects, objects for what? Not an object, organic molecules, because this is not physics, it's chemistry, right? I'm talking about objects. We don't have objects here. Okay, so when a molecule with the larger surface area, with a larger surface area, a molecule with a larger surface area, what does it mean? It means intermolecular forces. Intermolecular forces will occur at a larger surface area. I should have even said, we're comparing the two in terms of boiling point, right? The first one, the intermolecular forces will occur at a what? At a larger surface area. Molecule with a larger surface area, what does it mean? If a molecule has got a larger surface area, what does it mean? It means the intermolecular forces will occur at a larger surface area, right? Yeah. It's like this, guys. This is a smaller surface area. This is a larger surface area, right? Even if the intermolecular forces are weak, but because they are occurring at a larger surface area, it means they will have an impact. You understand? Yeah. What are we doing? We are comparing the boiling point of this one. Which one will have a higher boiling point between the two? This one. The boiling point of this one will be higher. Why? Because it is longer. Because it is what? Longer. When it is longer, it will get to have what? Larger surface area. And larger surface area, it means that the intermolecular forces will occur at a what? Larger surface area. When the intermolecular forces occur at a larger surface area, what will happen to the energy? More energy is needed. More energy is needed to break the bond. To break the bonds. Then what will mean? It will mean it will have is it low or high? High boiling point. High boiling point. Why is it having a higher boiling point? We are comparing two unbranched molecules, right? This one is longer, this one is shorter. Which one will have a high boiling point? The longer one. Why? Because there is what? It has got a larger surface area. So when you are talking, when you are writing, guys, don't just end at larger surface area. It have larger surface area. Intermolecular forces will occur at a what? Larger surface area, and more energy is needed to break the bond. Therefore, it will have high boiling point. Don't forget, you must say a lot of things. If you want to make bullets which are very visible, when I might, I'll just come and say, bah, bah, bah. And do not be confused, because I'm going to show you something. This one, there are no hydrogen bond, right? Whenever we talk about the alkanes, we compare the intermolecular forces of alkane. What do we address? We address the issues of surface area. I want to show you the second one. I'm comparing two straight. They do not have a branch, right? I want to give you a comparison when we've got two organic molecules, hydrocarbons, which have got a branch. Okay. When we compare a hydrocarbon which have got a branch and the one without a branch, do you know which one will have the highest boiling point? The one without a branch. Let's say I draw this one. 1, 2, 3, 4, 5, 6. Is everything okay? Okay. I have two hydrocarbons, the alkane, right?
Yes.
Both of them, they are hexane. Both of them, they've got 6 carbon in their longest carbon skeleton. Longest carbon chain, right?
Yeah.
The only difference is that this one has got a methyl group. It has got branches, right?
Yes.
It has got what? Branches. It has got the methyl. They've got the alkyl group, not the methyl group. The methyl group. They've got, we call them alkyl group. The branches, right? It's just that they are methyls. They've got the. So this one is bound to become 2. Is 2,4 dimethylhexane. Can you see? This one is branched. This one is not branched. This one is not branched. Branched. This one is branched. Branched. So, which one will have a high boiling point and which one will have a low boiling point? I want to show you when we have branches, right? The one which have got branches will have a low boiling point when we compare with a straight chain. This one is a straight chain. This one is a what? Straight. It's a straight chain, right? This one we say it is a branch chain. What will happen? What will happen? Which one will have between this one is A, this one is B? A will have high boiling point. Boiling point. Why? Because it is straight. That's how because it have no branches. It means branches, they cause something to have a low boiling point. Why? The question is why. I'll tell you now. Because it have no branches. It have got, what did I say? Yeah, it have high boiling point, right? Why? It have no branches. So now I want to tell you how because both of them, they have 6 longest carbon chain, right? But this, why am I saying this one? It have got the high boiling point. This one has got the high boiling point because it does not have a what? A branch. So it means there is something that branches does to hydrocarbons which causes them to have a low boiling point. Can I tell you?
Yes.
Okay. I'm going to finish this statement. Is that I must talk about branch before I ruin things and confuse you. What does branch do? What does a branch do? Branches. Branches. You know what they do? They cause a molecule. I wanted to say an object again. I've been over the spirit of physics. This is chemistry. They cause a molecule to be compact. To be compact. You know what does compact mean? Da, you don't know what compact means. You don't know what compact means. Okay. Can someone give me a paper? Piece of paper. Fast. Through this piece of paper which I'm holding, I want to demonstrate to you what compact means. Do you see this?
Yes.
You can see it, right?
Yes.
Does it have a larger surface area? It has somehow, right?
Yeah.
Compact means this. This is compact, right? Compact, it means that it coils because of the branches, right? And it forms a smaller thing. You understand? So when it becomes compact, it becomes small, compact. You understand? To be compact, let me go switch. That is to be compact. So now, you see, I had a very large piece of paper which Nkari gave me. Can you see? You see, né? So what happened? It became compact because of what? Of branches. You know what branches will do? They will cause this thing to turn and it become compact, right? So it means its surface area is going to be what? To be small, because if I had something like this, then it becomes compact. It means the surface area is going to be. So what do branches do? They cause the surface area to be small. It's like to be compact, it's like it coils. You know, to coil, right? It turns and becomes small. You understand? That is the effect of what? Of branches. That is the effect of what? Of branches. So branches will cause the organic molecule to be compact. When you are writing, and you are going to be given questions whereby you are comparing the one with a branch and the organic molecule without a branch. So just know that the one with a branch have got low boiling point because it will become compact. I want to say you're writing compact. So go. Compact. You understand? Yeah. You understand? Okay, thank you. It will become compact. You understand the meaning of compact, right? You understand now? So when we're comparing the two, the one without a branch and the one with a branch, it means the one without a branch has got a high boiling point because it is a straight. It's a straight. What am I saying? It is straight, right? It's a straight organic molecule. It does not have what? Branches. You understand? Yeah. Then the one with branches, it becomes what? Compact. It becomes compact. It becomes what? Compact. When it becomes compact, what will happen to the intermolecular forces? Intermolecular forces will occur where? At a smaller surface area. Intermolecular forces will occur at the smaller surface area. And when they occur at the smaller surface area, what will happen to the energy? Less energy is needed, right? Yeah. It's needed to break the bond. To break the bond. What will happen to boiling point? Will it be high or low? Low boiling point. Boiling point. What will happen to the vapor pressure if boiling point is low? High vapor pressure, right? Yeah. The vapor pressure is going to be high. It means something that easily boils. It can turn to vapor fast because vapor pressure, we're talking about the what? The vapor, right? Yeah. Is everything okay? Yes. Everything is fine, right? Did you understand? So there's no exam without this, man. Whether it's formal, informal, or whatever, it will be there. Be conscious of it. I want to teach you something else in terms of intermolecular forces. I will no longer be talking about alkanes. Because you see here, there's no hydrogen bond, right? We just express intermolecular forces in terms of surface area, right? It means we are going to compare a shorter molecule and a longer molecule, right? A longer molecule will always have a high boiling point because it have got intermolecular forces which are occurring at the larger surface area. More energy is needed to break the bond. Then a bright molecule and unbright molecule, right? The bright molecule is going to do what? It's going to have a less because it will become compact. The word compact, you must not forget it, right? It will become compact. I've showed you what to be compact is, right? Yes. So we're done. We're comparing the what? The alkanes. I know the students last year used to confuse things. Maybe I did not demonstrate it well. We're cutting here, guys. I don't want to see you talking about hydrogen bond. There's no hydrogen bond here. We compare the what? Surface area. So now we're jumping. I want us to address intermolecular forces, and we're going to talk about what? Hydrogen bond. Because hydrogen bond, okay, when there is what? North and hydrogen, right? North is a mnemonic for nitrogen, oxygen, and fluoride. Okay, thank God. Okay, let us continue. So look now, I want us to talk about intermolecular forces which involve hydrogen bond. We know that hydrogen bond is a kind of a bond which will exist between hydrogen when it is bonded to NO, nitrogen, oxygen, and fluorine. Right? Of which we won't talk more about nitrogen, but if you go and check your life sciences, you go and check the structure of proteins, you'll see nitrogen. I'm not sure if you are able to see that these organic molecules which I'm teaching you, you learned about them in grade 10, but you were not aware. Go and check the structure of a starch in your book, the structure of a protein. You'll see that it is the organic molecules which I'm teaching you that drawn the same way, right? So nitrogen, we find it in the structure of a protein. Okay, but that's a talk for another day. Here, let us talk about our own organic molecule. Let's say we have what? Let me just give you alcohol, OH. We want to compare the intermolecular forces between an alcohol and a carboxylic acid. Let me just give you a carboxylic acid. Let me give you a carboxylic acid. 1, 2, 3. I'm just giving you OH. 1, 2, 3, 4, 5. Immediately there 5, it is wrong. 1, 2, 3, 4, 4. Do we have a carboxylic acid and an alcohol? Yeah. You can see, right? Yeah. We want to compare their intermolecular forces. Listen, my people. Hydrogen bond, right? Hydrogen bond occurs between hydrogen and oxygen. Do you see hydrogen here? Do you see oxygen? Yeah. But which one will have higher boiling point than the other? Alcohol. Why are you saying alcohol? No, high boiling point, isn't it? When it is highly flammable, it means it has got the low boiling point. I thought. So look, the more, isn't it? Hydrogen bond occur between hydrogen and carbon. Hydrogen bond occur between what? Hydrogen and oxygen, not carbon. Where am I getting the things of carbon? It occurs between north, right? Yeah. Hydrogen bond occur between oxygen and hydrogen in this case, right? And nitrogen and fluoride. It's a mistake, the thing of carbon, it does not exist. Okay, so now, the more oxygen we have, the more, don't write this, because you are going to write and some people are going to mark you wrong even if it is correct. The more oxygen we have, right, and hydrogen we have, it means that particular molecule is going to have a stronger hydrogen bond because it has got a lot of hydrogens. Am I lying? A lot of hydrogen and a lot of oxygen. Do you agree? It's true, right? So between this one and this one, which one will have a stronger intermolecular force, the hydrogen bonds? This one, because there are many oxygens, you see, and there are many hydrogens, right? So this one has got less, although it has got hydrogen bond, but this one has got more oxygen, right? Don't write more oxygen, don't write. I don't want you to write in a wrong way because we went somewhere to a memo discussion, and as I was explaining these things to them, although it is very correct, they try to deviate. So let us do what they want. Ne? Yeah, let us do what. Don't write what I said with many oxygen, but it is true because this one has got more oxygen, this one has got less oxygen. It means this one has got strong, got hydrogen bond. The hydrogen bond is stronger than this one because we're going to have many hydrogen bond. So you know how when we compare, you know what we do? We say carboxylic acid. This one, right? And how many sides for hydrogen bond to occur, according to you? How many sides? Where and where will hydrogen bond occur? Where and where? How many sides, according to you? Isn't it hydrogen occur between oxygen and hydrogen? How many sides? 2. It's going to occur here and here, right? Yes. There are 2 sides, right? Yes. So carboxylic acid, they have got how many sides? 2 sides for hydrogen bonds to occur. Both of them, they've got hydrogen bonds, right? But this one has got 2 sides for hydrogen bond to occur. Do you agree? Yes. Then, what about this one? It has got 1 side for hydrogen bond to occur. Can you see that? This one has got 1 side for hydrogen bond to occur. This one has got how many sides? It's when we are comparing what? Alcohol and the carboxylic acid, right? Our exam guideline does not indicate that we need to also include the esters because esters have got a low boiling point. I told those people when I was explaining in the memo discussion that this one, because it has got a lot of oxygen, because these 2 sides, this one has got more sides because of oxygen, right? This one has got a lot of oxygen, this one has got few oxygen. They said that the esters, what about the esters? You know the problem with the esters is what? They do have hydrogen bond, but they've got a tail which is non-polar. So they have a low boiling point because the hydrogen bond is going to occur at a particular site. The hydrogen bond is going to occur at a what? So they get to have a tail which is non-polar. So since that tail is non-polar, it will make everything to have a low boiling point, right? I'm going to draw this. I'm going to show you why is carboxylic acid having stronger intermolecular forces and high boiling point when compared to the alcohol. Why is that? I'm going to draw structures because it's not like when we have alcohol and an acid, we have only 2. We have a lot of these things which form a very huge structure. I'm going to draw that structure for you and I'm going to show you how that is going to happen. Right? So when we compare the 2, we say that this one has got 2 sides or more sides for hydrogen bond to occur. This one has got how many sides? 1 side for hydrogen bond to occur. Okay. We are fine. Fine. Okay. Let's check if the question come. Now, this I was teaching you, ne? I was teaching you content. Now I want to teach you how we answer a question. Just to put the things which I said to you in what? In reality. The first thing that we need to do, I said give the what? The name of the intermolecular force. What is the name? We are comparing the two, right? Yeah. Which one? Which one? It's a question. Which one has a high boiling point? Which one has a high boiling point? Number one, we give the name of the intermolecular force. We say this one is A, this one is B. We say both A and B have hydrogen bond. You see, we have indicated the type of a intermolecular force, right? Now we are going to talk about the what? The strength of intermolecular force. We are going to say A have more sides. Some they can say two sides. A have more sides for hydrogen bond to occur. It's all right? But B has what? Less or one side, right? Less sides for hydrogen bond to occur. Or comparing the two. You see, we have addressed the issue of the type of intermolecular force that occur. We have addressed the issue that the sides. What does it mean? It means A has what? High boiling point. Boiling point. Because it has more stronger what? Intermolecular forces. It has got more stronger intermolecular forces. Is it not true? We need to choose a side. Because it has got two sides for hydrogen bond to occur, it means it has got stronger intermolecular forces compared to the other one. Do you agree? You agree, right? So then we talk about the type of energy. Remember I said we must talk about the type of energy as well. So it means what? More energy is needed to break the bonds. More energy is needed to break the bonds. Then we've already concluded, we've already talked about the boiling point. You understand? Because this one has got more energy is needed to break the bonds. It means what? It has got the what? Higher boiling point. They've got the higher boiling point. You understand, right? Then I give you 4 marks. Most of them, when these ones come, they come with 4 marks. So when you explain, you must give us information for both of them, right? Whenever you hear a question address the issue of intermolecular force, don't forget, give the name of the intermolecular force. Give the name of what? Intermolecular force. Okay. Is everything okay? Everything is okay, ne? So, thank you. We're going to end it here for now.